G'day, guys. So quite a while ago, Shane St. Pierre, he talks a lot about, that our globe maps are sort of designed by the stars and all that sort of stuff. And, we've had many discussions about, triangulating Polaris and the graticules being 69 miles per degree. So these are some of the numbers that he uses, right? Now, he says, maps are projected from these angles and all that sort of stuff. So I thought I might put it to the test, because the one thing that that actually happens, and forget all this, as soon as he says, this is what they say, blah 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 blah, it goes straight into perspective. Streetlights, absolute garbage. So it's just avoidance, absolute avoidance of the truth. But if you actually reverse engineer this sort of stuff, you can come up with some interesting scenarios. That's the thing. Most people who read this are not going to go out there and test it for themselves. They just read it and then they just take bullshit by themselves. So as you can see by this other website, this is geohashing.site. It does say here, the graticules is 69 miles by 69 miles, right? So I'm going to go with that. I'm going to use miles because that's what everyone seems to want to listen to, even though I would be thinking of about 111 kilometers in distance. And of course, as you can see here, the pole star, and finds it to be 45 degrees, and this can conclude that the latitude is 45 degrees north, right? So that would mean that if you're at 45 degrees north, you're in Montreal or in Seattle or something like that, and you try to identify where Polaris is, it's 45 degrees, from your zenith, and pretty much 45 degrees from the horizon. So I decided that I would try to punch this all together. Now, what I did was, there's 90 degrees between. Actually, sorry, this is wrong. I should have done it the other way around. So 69 times 45, actually, because that's 45 degrees what I'm trying to work for. 3,105. So from the 45 degree mark, there should be 3,105 miles to the North Pole. And when you're at the North Pole, Polaris should roughly be directly above. So what I've done is I had SketchUp here, and this line is a dud because I didn't think about what I was doing. But anyway, so 3,105 miles, right? So I'll just draw a line, 3,105. Okay. Now, from the center point, Polaris should be straight overhead. That blue line is basically when it is straight up. Now, if I take the protractor object, here we go, and if I bring that over there and I bend it down and I go 45 degrees, all right, so that's my 45 degree line, right? So it intersects right there. Now, keep in mind this chart is very, very small, which is a bit of a shame. Okay, so if you were at 45 degrees, if you were at the Montreal area, and you were 3,105 miles away from North Pole looks straight up to Polaris. This one looks 45 degree Polaris. This should be roughly where Polaris is. And this is the thing, is Flat Earth will never bother to go out there and try to figure out where Polaris is. They'll just say it's roughly over there, and they won't actually bother to try to triangulate, try to use any actual geometry. So when I do the protractor up here, I can snap to here, and I can point down here, and I can bring it to, say, 10 degrees. Do it again, and make sure that it goes green. That's fine. And then I'll go to 20 degrees. Alright, do it again. Click. There we go. We'll go with 30 degrees. And do it again. Make it green. There we go. Click, click. We'll go for 40 degrees, I think, here. Alright, so up here again. Please do it green. Thank you. Go to 50 degrees. Alright, so this is basically me inputting it for whatever latitude you are. If you're at, if you're 50 degrees down from the North Pole, basically you should be at 40 degrees north latitude or something like that. Right, so these ones which are 80 is basically up near Greenland or something like that. We're going for 60. And drop that there, and we're going for I think it was 70. Yep. And we go up here, down there again, and we'll go for 80. Alright, so what I might do is I might just color this thing for the moment, and then what I'm going to do is I'm going to draw this here. Now, I don't know if anyone's probably looking at this and probably going, I don't know what the hell he's doing. Well, that's fine. It's okay if you don't understand what I'm doing. What I'm trying to do is I'm trying to reverse engineer from a Polaris position what the actual rings of the latitude are for the flat Earth map. Now, if I just continue to triangulate here to there, triangulate to there, see all those times it brings up a little cross, that basically means it's touching the line. And I'm going to change this one to green lines. That's too strong. I might dull it down. Now, what is the scenario here, right? Is for every 10 degrees of angle to Polaris, you should get 69 miles times by 10, 690 miles, right? That's how much distance you should be getting from all of those latitudes. So let's just see what we get. So this one here, it was supposed to be 690. 583. That's not 690. 663. That's not 690. 800. That's not 690. 1095. That's definitely not 690. Well, these numbers keep on getting bigger. We went from 1095 to 1678. That's like 3 times as big as 690, or maybe 2.5 times as big as 690. What do we got here? 3,153 miles. Fascinating. That makes that part really, really, really long. How much is this one? 9,078 miles. Like, that's literally off. Like, that's like an entire hemisphere, pretty much. You're supposed to get 10,000 roughly. Well, no, sorry. From the American miles, I would imagine that you must get about the calculators here is 31, so it must have been like 62,000 miles. So in that last 10 degrees, from the 20 degree to the 10 degree, the amount of miles between those two latitude lines is actually greater than a full hemisphere. So this is a bit of a concern. I have a bit of a problem because I think that if I actually draw the protractor up here, like I was done before, right, and I rotate that to 90 degrees, right, this could be a bit of a problem. The 90-degree line goes on for infinity. I wonder if I wonder if Singapore is actually infinity distance away from the North Pole. Do you think it's infinity distance away from the North Pole? What do you think? You can answer in the comments. I mean, look, I don't know. I mean, I've flown to Singapore. It's it's like 8 hours flight. If it was infinity, I probably don't think I'd actually reach. I think they'd run out of petrol. They'd run out of fuel. I'll tell you what I might do is I might do 85 degrees. All right, so 85 degrees. Let's break it a little bit more even. All right, so 85 degrees. What have we got here? I'll draw this line further out. Now. And where is this? Actually targets there. There we go. It actually does target. So this was 5 degrees difference. All these ones were all 10 degrees, right? And I mean, mind you, it does say here 547, and this one says 9,078. What's the distance between the last 5 degrees of latitude? Where you're going from like Singapore to like Kuala Lumpur, just like a couple of hours drive, really. What sort of distance do you think is Singapore to Kuala Lumpur? 17,881 miles. That's like from the North Pole all the way through to the South Pole and then back around to the North Pole again. Because if I times 3105 by 4, it's more. So to the amount of miles that you would have to go, so you'd have to go from the North Pole down to the South Pole, back to the North Pole, and then round again, just to go from Singapore to Kuala Lumpur. Fascinating stuff. This is really, really, like, I'm so glad that when it comes to using the angles to Polaris as a starting point to be able to build a map based on latitude, using all those 1 degree angles for latitude, you can get some seriously quality circles. So I mean, as you can see here, this is the first circle. Let me just align myself just a little bit here. Let me do another circle. Here's a circle. Oop, no, I don't want yellow. I want the other one, guys. No. Okay, that's a problem there. There we go. Blue circles, much better. See, all these circles are all the inner rings. That's why, the distance of Canada, right? North Pole down to Canada. Oh, and as you can see there, that's where I got to Montreal right there. That's my first ring to Montreal. And this must be 40 degrees. So it's probably somewhere down New York. And do another ring. I think that it must have been like 30 degrees. So that's down to Miami, right? And this one's like down to like Jamaica, right? And that one there, that was 10 degrees. So that one's probably borderline, somewhere down near Venezuela or something like that. And this one here, this one was like right in the middle of Peru or something like that. So I mean, this is you see all these rings. All these rings are your latitude rings on your Gleason map. As you can see, the ring gets larger and larger and larger the further it gets out. It makes it really, 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 really easy to be able to place your country on the map. All you need to do is just for each ring, you just need to stretch it heaps more, right? So you squeeze Canada into this tiny little spot over here, but then you stretch Jamaica, and the Jamaica's like massive. You know what I mean? Really, really, really big. What I might do is I might do another protractor. I'll come up here. Let's get that green working. That's good. Yep. Let's go for 88 degrees. So it's just 2 degrees off the equator. So if I go for 88 degrees, come on, you work. Where is it? Come on, out in the red line. When I do the red line, essentially what I'm doing is I am aligning it. It's a nice straight line, right? So this is 88 degrees. Now, we haven't even reached the equator here, guys. The equator is just like, well, how about just for interest sake, right? I go up there, I stick it up there, put that there, and I go to 89 degrees, right? So really close to the equator, right? So really close to the equator. I don't know where the hell it is, to be honest. What's going on here? Let's just keep this line going. I might have to get rid of my equator line because it's starting to confuse things. Let's just get rid of the equator line because it's not working for me. I've gone blind just looking for it. So that's all those. I'm going to get rid of all those. Where? Bugger. I got rid of the thing. I'll do it again. Just one sec. So up here again. Boop, boop. Okay, I'm going to 89 degrees. Punch, punch. Go. So here we go. Oh, shit. It's gone way. Oh, here we go. All right. So that's the equator, guys. We are 1 degree away from the equator. And let me just punch in my latitude ring from there. Oh shit, the thing's going to break. Oh, look at that. Okay, so there you go. So that's the last 3 degrees of latitude ring. As you can see, the distance, I'll get the distance to, where's that angle? There we go. So that was 82 degrees right there. And from the equator. Okay, so from the equator, that's 1 degree from the equator. That's 2 degrees from the equator. This is 5 degrees from the equator, got it? So let me just have a bit of a quick look. So the distance between this, like, give me a thing. Man, the dimensions are bloody broken. I can't even get it right because it just won't work. How about I do distance? I'll do the measuring tape. It'll be good. What do we got? 53,425 miles. 53,000 miles. So if 12,400 miles is the distance it takes from the North Pole to the South Pole and back to the North Pole, this is 53,000, which means it is 4 times, about 4 times the size. So from the 5 degree line to the 2 degree line, you are looking at a distance of about four Earths just to get to it. Look, I'm sure people probably already figured out by now what the hell the problem is. This is just the radiuses on these latitude lines is just getting bigger and bigger and bigger. That's what happens when it comes to triangulation. You just can't do it. So the distance from the 9 degree north line to 1 degree north line, so 1 degree away from the equator, is 177,850 miles in distance. How much is that? So let me just have a quick look. Now, let me just punch it in. So 1,700 miles, 850 miles, right? Now, I believe an aeroplane goes 600 miles per hour. So let's divide that by 600 miles per hour. It's going to take 296 hours 296 hours for someone to fly from the North Pole to the equator. 296. Let me just divide that by 24 hours. 12 days. Okay. So according to this particular graph, it's going to take 12.3 days for someone to fly, and they're just going to have to refill and refill and refill non-stop. 12.3 days to fly from the North Pole to Singapore. Yeah. That's how maths talks about latitude lines on a flat Earth. It's brilliant, absolutely brilliant. Shane, I hope you see this, because you're an idiot. Got it? This is fucking stupid.